Okay, so I pulled up a student's attempts on a few questions. The first question is, which of the following is the correct set notation for the set of perfect squares between 1 and 100? So that means we want our variable to be something that's squared. That's why they all start here. If the question said, which of the following is the correct set notation for the numbers between 1 and 100, then we wouldn't use p squared because we're not talking about squares anymore. We just say p for this part. Okay, so the first part of set building notation is talking about like what type of number you're trying to define. In this case, a perfect square, so p or x or whatever variable you want being squared. And then it needs to be between 1 and 100. It says between 1 and 100, but then it says including 1 and 100. So that's probably going to be the key detail here. So this first option that we have to choose between, z means an integer. It's not really z, but the z looking thing means an integer. And r means a real number, which means integers plus all those decimals in between them. If we're talking about perfect squares, then we're not talking about real numbers, right? They don't, I mean, they are real numbers, I should say, but we're not talking about all real numbers, okay? P has to be some sort of integer to be a perfect square. Has to be a non-decimal number. So we can rule that one out. And then the only difference between these now is either having the or equal to symbol here in the bottom or not having it. Okay. And the key detail here is when they said including 1 and 100. So you have to have the or equals to symbol in order to give yourself 1 as a possibility. So if p equals 1, that's a possibility with this one, then 1 squared gives us 1, so we've included 1. And if p equals 10, like this says that we could have as a possibility in our set, then 10 squared gives us 100. So this is our correct answer. The reason why this one is wrong is because this is excluding 1. This says 1 is not a possible value for p because it doesn't have the or equal to symbol down here. Same thing over here. This is excluding 100 as a possibility because you can't plug in p equals 10 over here. Okay, so that one's a bit trickier. If you were lost, just hang in there because we'll go to an easier one, and maybe the harder ones will make more sense once you get used to the easier ones. So this question asks us to use set building notation for the set of all odd integers. So in this case, odd integers are the numbers we're trying to describe. In this one, we were trying to describe perfect squares between 1 and 100. In this one, we're trying to describe odd integers. For something to be odd, all you have to do is take any integer you can think of, double it, and add 1. Or you could say any integer, double it, and subtract 1. That would work. Because pick any integer, pick any non-decimal number in your head. If you pick 10, 2 times 10 makes 20. 20 plus 1 makes 21. That's an odd integer. Pick another one. If you pick 7, 2 times 7 is 14. 14 plus 1 is 15. That's because in math, this makes an even number. If n is an integer, this gives us an even number. If you add 1 to an even number, you've bumped it to be an odd number. Okay, so the set of all odd numbers are either these two. This one would be talking about even numbers, and this one's talking about odd or even. Okay, so the set of all odd numbers, but look at the difference between these two. This one has an x and this one has an n. If the variable we're talking about over here is an n, then the variable we talk about over here must be an n, so that one's ruled out. So this is all odd numbers such that n is any integer. This one might seem close, n such that 2n plus 1 is an integer. This would mean that you get an odd number that is an integer. That's a little bit in reverse. You want to be talking about odd integers such that the n you choose is some sort of integer, just like we set up here. You can't put a decimal number in here and get out an integer. Then what is the correct set building notation for the set of all integers excluding 0? So we want all integers, that's the number we're talking about. So this would be integers, that's fine. We can have p there, but we can't have x over here if that's the case. So we can rule that one out. Those two things aren't talking about the same letter. X is an integer, that's good. X is an integer, that's good. But remember, this r means a real number, so we exclude this one. So it's got to be one of these two. The set of all integers excluding 0, that means x does not equal 0. So this is our correct answer here. This is all integers such that whatever integer you pick is not equal to 0. Picked a few more here. Use set building notation to express the set of all positive even integers. So we just said a positive even integer could be 2n, but in this case they use x instead of n, so that's fine. So this is even integer. This is an even integer. This is an even, oh, sorry, well this one is not an integer because it says x is a real number. So 1.1 is an option. 2 times 1.1 would not give us an integer, and they want us to talk about integers. The set has to be positive and greater than 100. Okay, so that's easy because if you're greater than 100, then you're guaranteed to be positive, right? So this one is x is greater than 100. Oh, but it's an even integer greater than 100. Okay, so that's tricky. This one looks good, but this one is actually the correct answer, and here's why. Because if you plug in x equals 100 and it says even integer, so if you plug in x equals 102, then that's the lowest number you can possibly get that's an even integer, right? Well, no, actually, if you plug in x equals 101, 2 times 101 is 202. That's the smallest number that can come out of this set. X has to be some number bigger than 100. So if you pick x equals 101 and go back to this formula, that means 202 is the smallest number we can get. That's not even integers strictly greater than 100 because we're missing a bunch of other numbers like 102, 104, 106. So that's why this top one is not correct. Okay. So that's why this bottom one has to be correct. Because look, the biggest number you can get, that's an integer here, is x equals 51. If you plug that back into our definition for what these numbers can be, 51 times 2 is 102. So that is even integers strictly greater than 100. That means not equal to 100, only greater than 100. So that's why this one's the correct option. Okay, I think that might help with these questions. Pick a number that satisfies this condition, plug it back into this formula, and see if it's matching this criteria up here. Like this formula says x has to be greater than 100. Okay, so let me try x equals 101. Does that work out? If I plugged 101 back into the original, I get 202. That is greater than 100, but that's not all the even integers greater than 100. So that's why I was able to rule that one out. Set building notation denotes set of integers that are greater than or equal to -10 and less than or equal to 10. Okay, so set of integers, we need y to be the set of integers. So this is integers, integers, integers. Remember, z is integers, r is real numbers. That includes decimal numbers. So we need y to be greater than or equal to 10, but less than or equal to, greater than or equal to -10, less than or equal to +10. So this is our winner, because this one says 10 is less than or equal to y, which is less than or equal to -10. So how can 10 be less than y when y is less than -10? In math, we do things from least to greatest, just like we read a book from left to right for our reading convention. In math, least to greatest. This is greatest to least, so that's why you can rule that one out. This one is least to greatest, so that's fine. But it says greater than or equal to. The or equal to symbol would be a line underneath here, so that's why we got to rule this one out. It's missing that line.